Hi everyone, welcome back to our daily questions and solutions. So today, this would be the last question on reaction kinetics. I believe we've gone through most of the common question types in reaction kinetics. So the next topic that we'll be going on to will be chemical bonding. So this is a combination type question whereby you can derive the order of reaction using two different methods. Number one, by looking at the shape of the graph, and number two, by comparing the half-life of the reactants. So let's take a look at the question. Substances X, Y, and Z react according to the following equation. X plus 2Y plus Z give you 2W plus U. To find the rate equation for the above reaction, two sets of separate experiments were performed, in which the initial concentrations of each of the reactants X, Y, and Z will vary in turn, the other being kept constant. So we have the results. So let's look at the first graph on the left. So over here, we always look at the reactant on the y-axis first. So with respect to X, the order is definitely 0. How do I know? Because look at the graph, it's a line. Remember, if it's a straight line graph, when you have concentration of the reactant versus time, it is 0 order, right? And then next, so over here, although they gave us two different lines with different concentration of Y, however, it is more difficult to determine the order from here. So I'm going to derive that from the second graph on the right instead. So let's take a look at the second graph on the right. So again, look at the y-axis. That is Z, right? And then you look at the shape. Well, it's a curve. So for curve, you know that if you get this type of curve, for a concentration on reactant versus time graph, it's either first or second order. So how do you determine which one is it? You look at the half-life. So I start from roughly 0.08. Half of that would be 0.04. So you can actually start from any of the graph. I, of course, recommend starting from the one that's closest. So therefore, half-life 0.04, and the time taken is this unit. It's half of the box. And then the second half-life will be when the concentration decreases by half again, meaning 0.02. So you can give an estimate here that this first half-life is equals to the second half-life, right? It's roughly the same. So since first life equals to second half-life, then I know that this is a first order reaction. So therefore, this is what I have here. Next, I'm going to look at the order with respect to Y from this graph. So you can determine the order of Y through two methods. Number one, initial rate method, meaning you draw a tangent to the graph at t equals to 0. So I'm just going to illustrate this. I don't like this method. Okay, but I'm going to illustrate it just so you know. So you draw the tangent to the graph at t equals to 0, and then you, using points available, you calculate the gradient of these tangents. And then you compare how the tangent changed when the concentration of Y changed. And then you'll be able to derive the order. So this is known as the initial rates method. Unless the question specify and say that you have to use this method, I recommend you not to use this, okay? So my preferred method is also the half-life method. So you look at 0.04. Okay, and then I'm going to extend this. I'm going to find the time taken for the other graph when concentration of Y is 1 mole per dm cube. So it's here, right? And then you compare these two. So you see, the first one is only this area, right? And then the second one is from here to here. Do you see that the one in purple is 4 times of that in red? So therefore, what does this tell us? When concentration of Y increases by 2 times, time taken decreases by 4 times. So therefore, you know what is this? This is definitely second order. So therefore, when I simplify this, rate equals to K. If it's power 0, I don't include it because that's just 1. So this is it. So therefore, the answer is C. Hope that you understand this. Thank you for listening and bye-bye.